Although we have already seen meaning of the heuristic function in our previous classes. As I got the input from the many students, what is mean by the heuristic function? So just let me give you some idea. As we have already seen that an informed search. I'm speaking about the informed search. So if talk about the uninformed search, we have seen the what is mean by the uninformed search and informed search. If you remember the informed search, what are the algorithms we have seen? A star algorithms and A star algorithm and greedy search are these are the some example we have seen in the informed search. But when talk about the uninformed search, we have seen the BFS, UCS, and DFS as well. So now, if talk about the uninformed search that make use of the heuristic functions in order to reach the goal node in a more prominent path or way. That is the word. So we are reaching from the starting node to the goal node by choosing the prominent path by using the informed search mechanism as we have seen in the heuristic function. And heuristic function we have used in the, if you remember the my words, if you have we have used the heuristic functions in the informed search, and that was the A star. Okay, so if you remember the my words, A star and greedy search we have seen in our numerical we have also discussed. So therefore, there are several pathways we have in a search tree to reach the goal node from the current node or starting node, we can say. The selection of the good heuristic functions matter certainly. A good heuristic function is determined by its efficiency. So how we can measure the efficiency? That is the cost. So based on the cost, we have already decided, we have already received the information of the good heuristic function based on the its path cost. So more is the information about the problem and more is the processing time. So these are the some parameters we have already used, and what is the problem we are having, what is the things we are having. So the things depend on the problem as well. So efficiency of the problem can also be depend on the problem as well. From this parameter, if you remember the two types of the problems we have discussed in the problem formulation after the problem formulations part. That is a toy problem we have, and we have the. Can you remember the points? What are the two types of the problems we have seen? What is the toy problem, and another one is a. Yes, tell me. Toy problem, and another one. We have seen two types of the problem. One is the toy problem, in which the 8% problem, 8 queen problem, tic tac toe we have discussed, and other one was the real problem, real scenario based problem. That is dealing with the real scenario. So that was the part of the problem we have discussed. So if I talk about the our example, and you can see, I will share you after the couple of seconds. I will share you. But before that, what is the problem we have seen? We have seen the toy problem, such that 8 puzzle problem, 8 queen problem, and tic tac toe game we have seen. That can be solved by the many efficient with the help of the if you, with the more efficiently with the help of the heuristic functions. So let us move to the this example first. This one. Now tell me, you are able to see this example? Yes, tell me, you are able to see this example or not?
Yes, sir.
Yes, sir.
Okay. So now you can see this example, and this example is an example of the 8 puzzle problem, where we have to start. We have a start state and a goal state. There are 2 points we have. So our task is to slide the tiles of the current state, or we can the start state, and place it on the order for it in the goal state. And there can be the 4 moves that is left, right, up, and down. So there can be several ways to convert the current or start state to the goal state, but we can use a heuristic function to solve this problem with the help of the more efficient manner. That is the point. Okay, so heuristic function we will use. That is the point. So now in this example, you can say a heuristic function for the 8% problem we can define as below Hn. So Hn is what, that is the heuristic function. And how we can define this Hn? Number of the tiles out of the position. Okay. So there is a total of the 3 tiles out of the position 6, 5, and 4. Are you able to see? These are the unordered way we have the 1, 2, 3, 8, and 7 on the right position. You can see. Is it visible to right now? 1, 2, 3, 8, 7 are on the right position, but 6, 5, and 4 are not in the order. So we have to use these 3 tiles to change its position to get the our goal state. So by using the definitely by using the empty tiles. So present the goal state. So Hn would be the 3, and now we require the minimize the value of the Hn is equal to 0. Okay, so now problem is clear, or should I explain the problem once again?
No, sir, it's clear.
Okay, so I'm expecting everyone will be involved here to speak something over here. So those student who is not able to understand the problem, so let me explain this problem by the simple way. See, this is our start state we have, and this is our goal state we have. So start state and goal state is given. So you can say 1, 2, 3, 8, and 7 are on the matching with our goal state tiles. But when talking about the 6, 5, 7, these are not matching, because you can say 6, 5, 4 are not matching. So by choosing an empty tiles, we can do the shifting by choosing the some operations or actions. What are the actions? As I told you, up, down, left, and right. So from this point, we can say the our Hn, that is heuristic functions, can be defined as a 3, because we are shifting the 3 tiles between the 3 tiles. So now we require to minimize the value, that is Hn should be 0. So our objective is already defined, that is to minimize the value of the Hn equal to 0. Yes, so what you have to design from this problem, what you have to design, what are the points? So I'm writing some points. First point, uh, use left, right, up, and down movement, or you can say the movement or shifting. Let me write correctly. Yes, the movements. Okay. Second one, you have to minimize the value of heuristics, that is n equal hn equal to 0. And what is the n? N is number of tiles we are using. These are the few things which is already given. So our objective is what? So what is our objective? Our objective is design or represent your search space tree. To design a search space tree, we can say like this one: search space tree using heuristic function heuristic function to minimize the hn equal to 0. So that is our objective. So although we have written, so I'm not writing much more. So design a search space tree using the heuristic function, and this is objective. So the problem is given, the problem is clear. Now start state is given and goal state is given. So now you can easily draw search space tree. So let us understand all this problem by asking some question to you. So the problem is clear. Let me right now. The problem is clear.
Yes, sir.
Okay. So can you solve this problem at your end, or should I
Yes,
share
sir.
Should I share the solution?
So first, let we share.
Yeah, okay. So first do one thing, just you can use a paper and pencil to solve this problem and tell me how you're solving, then I will share the solution.
Okay, sir. So,
Okay.
sir, the
Yeah,
first we move 4 up.
just give me 1 second. Let me take in a blank slide. Okay, so I'm just drawing here, and then you have to speak. You can use your paper and pencil. First, I can give you one idea over here. If we're talking about the eight puzzle problem, this is the eight puzzle problem. Am I right? It is clear right now. This is the eight puzzle problem. So how many tiles can be? So how many tiles we can?
uh, n plus 1 matlab 9,
Okay,
sir.
9. So 8 plus 1, that would be the 9. So here we can say 3 by 3. Yes. So I hope you have already gone this kind of the problem. Is it true, or you just understanding this kind of the problem first time?
It's
Yes, tell me. Okay, and 868
well,
5 and 4. This is a start state. And the whole state is already given over here. So we are using this one, and you have to tell me how we can solve this problem. So other students also required to involve here to understand this problem, because in the examination, what I will give you the any kind of random values, or in the form of the start with state. You have to use the some movement. You have to define the heuristic function. So 1, 2, 3, 8 are on the same
8
position. Okay,
and 7.
and 6 by 4 we have. So 4 will come here and this will come here. So this is our goal state. So these two things are already given, and now you have to use your idea to tell me the answer. Before that, let me change the color for notes purpose, so it will be benefit for us. Yes, tell me what we can do first.
All we move 4 up.
First, what I will do, okay, you can speak. Uh,
4
where I
up.
have to, okay, so 4 up.
Yes, sir.
Okay, so 1, 2, 3, I can write as it is. 8 and 6, I can write. No, sorry. Let me write correctly. This would be the 7, and this would be as it is. This would
5
be
and
this one, and so 4
4.
will come over here. So this is the way.
4.
Okay,
And then, sir, 5, right?
okay. So we can do the 5, right? Okay,
And 6 down.
and 6 you can do a down. So your
Yes.
solution your will get. So this is the solution. Yes. So you have done this thing in a one attempt only. So what are the other possible option? See, you're on the right track. I'm 100% sure. So if I'm talking the search space tree, so we need to find the possible paths. Let me explain. Can we use like this one? 1, 2, 3, and 8, and 7, 6, 5, 4 is given. So we have a first option as the student is telling to us. We said we can do the up 4 up. So if we're talking about the search space tree, so our answer or solution should be represented by the tree mannerism. So I can write like this one. If he is saying, so we can do the up 4 up. So I can write 1, 2, 3, 8, 6, and 4 will come over here, and rest of the 4 tiles will be on the same position. And third option, according to him, second or third option, I can write over here or draw over here. We can have 1, 2, 3. So what is the other option? We can take the 5 right. So we can take the right 5. So But before that, what are the other possibilities? That is the point.
We can move in clockwise direction, like 6 right, 5 up, 4 left, then
See,
6.
that is the point. From the start state, what are the possible movement we can take as an initial level? So as an initial level, we have done the up four, so we can do. So we have used we have done this thing. But if talking about the right five, so how it is possible? Right five is possible or not? From the start state, six right is possible. Right five is not possible.
Yes, sir.
Okay, so
So,
we
sir,
can
5 up is possible then.
then 5 up is possible. So we can expand such a point. So, but here to as initial level, we can not do the right 5. We can do only the right 6. So 6 will come over here, 4 will be as it is, and 5 will be as it is, 7 will be as it is, and this will be as it is. So what we have done, we have shifted here, this 6, okay, on the right side. Any other possibilities we can have?
Yes, 5
Yes,
up.
tell. No, no, no.
Acha, in different way. No, sir.
No, no. As an initial label, what are the, as initial label, you have the three options. Let me explain. That is the point. See, as a good perspective, we have to follow. See, this is your initial state where this block or this tile is empty. Tell me yes or no.
Yes, sir.
Okay. So, what are the first point you can do the up for? This is the first possibility I can do. Tell me yes or no.
Yes, sir.
Second possibility I can do 6 here by the right 6, is it?
Yes, sir.
And third possibility we can do 3 down. So our this would be like this one as initial level. The third one was our we can do the 3 down. So 3 down we can do, and 4 will be as it is, 5 will be as it is, 7 will be as it is, 1 2 will be as it is, 6 I will not change, and 8 will be as it is. Now the problem is clear right now. So what we are doing as an initial level, what is the possible movement we can do, and then from the possible movements we have to take the next step to solve it. So what we are doing the down 3 as initial space. Now it is clear right now.
Yes, sir.
Okay, so
Yes, sir.
from this point you have to choose the appropriate uh, diagram or the label where you can move. So if I take the right six part, if I take this part, is it possible? We can do, and it is possible or not. So we have to do. From this point, you have to define the heuristic function as well. That is very important point in our mind. We have to. So what is the heuristic function? As I told you, if you remember my previous one, so you have to tell me the heuristic function value as well. So number of tiles out of the position. You have to find how many tiles out of the position we have. So if you talk about the heuristic value at this level, what would be the heuristic value? Hn equal to, just can anyone tell me what would be the value of the heuristics? How many tiles are out of the position?
2, sir.
2. Okay, tell me, think and tell me.
3, sir.
Okay, if 2, then how? If 2, then how? Because you need to justify the answer properly in the exam time. So that is the reason. If you're talking about the up 4, so what would be the answer you can?
Sir, if we are talking about a 4, it should be 2, sir.
Okay, just could you tell me the answer why 2?
So
Justification.
5 and 6 are not on the position.
5 and 6 are not on the position. 1, 2, 3, 4 are on the position. So 6 and 7 are not in the position. So heuristic function will be the 2 as per the our problem. And that is saying to the number of tiles after the position. Now it is clear.
Yes, sir.
So why 2 we are getting? Because 6 and 5 out of position. Can you also define this heuristic function value of the right 6?
3, sir.
Okay,
3,
so
sir.
okay, so can you tell me how we are getting the 3?
Yes, sir, because
6.
all of 6, 5, 4 are out of position.
Yeah, it's a good. It's a brilliant answer. 6, 5, and 4 are out of the position. Okay, this is a good way you're learning something properly. And what about this one? Down 3 I'm choosing.
4, sir.
4, sir, 4.
Okay, tell me.
Sir, 2, sir, 2, because 3 and only 3 is out of position here.
No, sir. 4.
Sir, 4, sir.
Okay, if
3, 4, 5, 6.
3, 4, 5, 6. Okay, so this is very important point. Yes, tell me right now. Think and tell me. You can take your time to understand.
Sir, 1.
Okay, 1 then y, and 2 and y, 3 and y, 4 and y. So the student who is picking 1, tell me why, and the student who is picking the 2, 3.
Because only 3 is out of position, rest are in their respective positions.
Okay, the student who is picking the 2, just can you justify your answer? Yes, that is very important point, because you are defining the heuristic function. And what is the heuristic function? Based on the problem, we have defined the heuristic function, that is the number of the tiles that should be out of the position. So yes, just tell me right now.
Sir, all 4, 6, 3, 5, 4, all are out of position, sir.
Yes, sir.
Okay, and the student who is speaking about the 3, so just can you justify? Yes, tell me. Just think and tell me. The answer is in front of you. Okay, can I say the answer is the 3? Heuristic function will be the 3. Just now tell me. Just tell. Can I say the heuristic function of 3 would be the right answer?
Sir, I don't think so, sir. I
You
shouldn't.
yeah, see, I have the proof. First, you can think and tell me. Else, I have the proof. See,
As we are moving 2, 3, 6, 5, and 4 for the final result, so it should be 5.
see, you are not again not thinking about the heuristic function. Number of the tiles after the positions. Now, this point is clear. The heuristic function number of tiles after the position. It is clear right now.
Yes, sir. Yes, sir.
Yes, sir. Okay.
Okay. Okay, so just look at the our start space and this state. So start state, you can say 1 is now on the position and 2 is also on the position. 8 is also same position and 7 is also same position, by which is matching with our goal state. 1, 2, 8, and 7. Is it true?
Yes, sir.
Okay. And what? So if talk about the 6 is not on the position, 5 is not position, 3 is not position, and 4 is not position. Okay.
Yes, sir.
So with these points, you have to do the force shifting. Then you can get the answer. First, what you will do? There's no need to shift the 3. So the reason is that 6, 5, and 4 are out of the position, which is if I try to match the solution by our goal state. So that is the point. These are the out of the position. You can say 6, 5, and 4. 6, 5, and 4. and there's no need to shift the down over here. So why we are moving down? There is a possibility we have taken, but there's no need to, because with this shifting, our order will be changed. So we will keep this position as it is. So from this point, our heuristic function, as we are deciding, that should be the 4, but that should be, we have to 1, because the reason is clear. If I'm shifting the 3, so my order will be suffered unnecessary. So why I'm changing? I'm just disturbing this 3 type. So I need to keep as it is. So this is the reason we have to again, uh, we can do the 4 shifting or 4 movement after downing the 3. So that is the reason we will not touch this. So we will keep as it is once again, and we have to think again, that is a 3 shifting is available. So based on this parameter, the heuristic value will be of this parameter, that would be 3 only, because 6, 5, 4 are not on the right position, as which are not matching with our goal state as well. So what you will do, 3 you can again shift to the as it is position, and then you will work with the 6, 5, 4 only. So this is the reason. So heuristic function is more, as the name suggests, you discover something. So we have to discover. So we have to discover the right path. So 3 will, it is not required to this part. So this is it. So we will not go with the down 3 part. So we have two options now. We can go with the up 4, or we can go for the right 6. So from this point, you have to choose these two parameter, or these two space, where you can forward, or where you can expand your problem. So from this point, we have to again expand our problem. Now that is the point. So the heuristic function, we are choosing 3 only here. The reason is clear. We will not need to disturb the 3, because it is already in the order. So why are shifting? So after downing, again we go back, and we will, after applying the back, so heuristic function we can find only 3. So that is only reason the heuristic function will be the 3. What is our objective? The heuristic function should be minimized. So if you are increasing the heuristic function value 5 and 4 and 6, so there will be no sense. Our objective, that is the heuristic function should be minimized. That is the mind. Now it is clear right now why you are increasing the heuristic function value. Okay, so from this point, now what we have to do?
Excuse sir.
Yes, tell me.
Sir, can you please explain that why don't we count it 3 shifting, sir?
See, the reason is clear. Okay, I can take the different this one. The reason is
Sir,
clear. Yes, 1, 2.
now we only have two possibilities left. We don't have to work on this.
No, I'm coming, but just let me clear the answer of the student who asked me the question. Then I will ask you a question. Okay.
Okay, sir.
So the student asking me, sir, we have the 1, 2, and 3. This one, and 8, uh, 6, and 7, 5, and 4. This is our start space we have given, and I'm choosing the 3 down over here. You can do, but if you're shifting down to the 3 on the downside, so you are changing the order. So that will be no sense. So if you're doing, so what you are doing, you are trying to calculate the heuristic function. First, you are increasing the heuristic function value. So after shifting the 3, so you will work with the 6, 5, 4, and 3. That is shifted. So why you are increasing the unnecessary heuristic function value? So that would be the 4. So this is the reason it will take extra memory, or necessary memory, we can say extra memory and time, extra memory and time. So why you are doing? Our objective is clear. Our objective is what? That should be minimized to 0. So if you are looking for the increasing, so there will be no sense. So this is the reason we will not shift down 3. For the possibility, we can say. So this is a diagram on the right, extremely right, which is drawn about the down 3. That is showing to that we have the possibility, but this possibility doesn't have any kind of a sense. So that is the reason, and this seems to us over the start space. So from this point, we will shift only the 6, 5, 4, and again no need to. So we will keep the 3 as it is. And from this parameter, we can say 6, 5, and 4 tiles are our unordered or not in the our order as we have seen the goal state. So this is the reason we can say the our heuristic function would be the 3. So I'm reducing the 1. Just this one minus 1, what I'm doing, result is clear, just applying to the back position. So we have to think about the property. So this is the reason heuristic function will be a 3 only, not the 4.
Okay, so means that we don't have to count the unnecessary shifted.
Yes, this is a good point. See, you are just sitting on the right position, and if I'm as a faculty, I'm asking you why you're sitting on this position. Just can you sit to the here so other student may sit on the right position. So why I'm sitting? So if I'm sitting you unnecessarily, so I'm increasing your extra memory and time to utilize your sitting position. So this is the reason. So we will not do that one. So this is the reason down 3 we will not opt. So that is the one reason we have got. So now we have the two options. We can expand the up 4 space tree or space part, or we can expand the right 6 part. So tell me right now which part I must take to expand my solution to reach the goal state.
So with minimum heuristic value.
Yes. So what is the minimum value we have over here? 2 or 3?
Set 2 with up 4.
Yeah. So that is a good point. So let me write this one. So from this point, you can easily check HN2 is smaller than the HN3. So what you will do? Again, you will expand this one. Okay, just for understanding purpose, I'm writing. We will expand over this space tree to reach the goal state to get the desired solution. So after shifting the 4 here, so what would be the next possibility? That would be the right 5. Can I say?
Yes, sir.
That's a
Yes, sir.
right 5. Yeah, so right 5. So after right 5, we have to again use the another space we can expand. So that would be the down 6. Okay, so these are all the points. Now, let me share the solution after understanding this point. Then you need to ask any question you have. Just look at the right 6, up 4, up, down 3. And all the heuristic functions are written over here. And right 5 after choosing. So we were on this position. We have selected this one. Okay, so it contains the heuristic value 1 over here only, and if I'm choosing the down 4, there will be no sense if it is required. So it just required the 3, and after this one, what I will do, I will choose the down 6. So I'm reaching to the HN equal to 0. So this is my goal state. So what is the correct path I have chosen? So let me write here with the highlighter. Yeah, this one. This is a correct. First I'm choosing the up 4, then I'm choosing this one, then I'm choosing this one. But other part I have to write over here to check whether it is correct or not, because a tree can have the many branches as we know the basically, but there is a guarantee every branch is nursing the fruits and flower. There is no guarantee, but we have to look the other side as well. We have to look at the other branches as well. So we will choose only those branches which are contained, which are just holding by the number of the fruits in the large volume or good flowers. That is only reason. So this is our goal state. So now this is what this is known as our space tree. I can write over here. Let me write correctly. Okay, this is known as this is known as uh, solution as a search space tree, or in some books it is also written space search tree. Space search tree. So as a basics or from the common things we will use the word space search tree. So in the exam time, if I ask the question, the problem is given and draw the space search tree to minimize the heuristic function value, then you have to write the or you have to draw the all the possible. In a one page, you're not able to solve this problem, so you can use the multiple pages to sort out the problem, but you have to take the very uh, a high speed to solve this problem because it will take much time to draw the different blocks again and again. So keep in mind all the points. So this is our solution. Now we have minimized, as you can see on the slide as well. So we will not use the heuristic function, that is a rule. So 1, 2, 3, you can see 1, 2, 3, 4, 5, 6, 7, 8 are which are matching with our goal state. Now it is clear right now how we are getting all the points. Now any problem so far?
Sir, I have one question, sir.
Yes, tell me.
Sir, let's say about hn बराबर one position.
HN बराबर one position. HN equal to one position. You mean to say it?
Sir, then how can in one step, in down 4 step, it can come like hn equal to 3?
You just tell me.
Sir, if we move 4 downside, 5 will automatically move left side.
No. See, this is you're talking about this point right now. Am I right? Just tell me. Yes, you're talking about this point.
No, sir.
Okay, so tell me.
Sir, hn equal to one position.
Okay, for the problem, I can write over here. Then we can discuss. So HN is equal to 1. Yes, tell me.
One position and sir down 4 and then it is coming hn equal to 3. So sir, in one step, how can it possible, sir? Sir, first we have to move 5 left side and then 4 downside.
See, okay, you you have to just see. We are choosing this point right now. Now it is clear.
Yes, sir.
So I can write over here 1, 2, 3, 8, 6, 4, and 7 and 5. So you have the two options. Either you can down this one or you can do this one.
Yes, sir.
Okay. Here, what I'm doing, if I'm just using the 5 as a right. So now we are getting this one. I'm just marking the circle. It is possible right now. It is clear right
Yes,
now.
sir. Yes, sir.
Okay, so the heuristic function is that how many tiles are in not in the good position. So what is the position? So if I'm writing here hn equal to 1, it means only the 6 is the tiles which is not in the order 1, 2, 3, 8, 7, and 5 are 5 and 4 are in the matching with our goal state. So we can shift to the 6 only to get our desired solution. So that is in hn equal to 1 would be. Now, if I'm talking about the down 4, so if I'm doing the down 4, so again you are getting the 1, 2, 3 are on the right position, 8 and 7 on the right position, but 6, 5, 4 are not in the position which are matching with our goal state. So
No,
here,
sir. That's not my question, sir. I have don't any doubt about hn. I am saying, sir, that if we are pushing 4 downside, then first we have to push 5 on the left side.
okay, I'm just drawing and tell me right now because without drawing this point, the thing will not be clear. Okay, so tell me 1, 2, 3, and 7 and 8. Okay, tell me what position.
So hn equal to 1, sir. The one you have circled.
Okay, so 1, 2, 3 on the third side, third down, you can say. This is the 6, and this is the 5, and this is the this is 6. This is the 5 and 4. This is the 5, and this is the 4.
Yes, sir.
Okay, so in this case, what is the problem?
Sir, I'm saying that in just one step, in your solution, the answer is that 4 is downside,
Hmm.
and then 5 is automatically on pushed toward left side.
Hmm.
I mean, there is no specific step then that 5 is left side and then 4 is downside. It is only 4 downside and then hn equal to 3.
This is the
So
right position.
by the total means, sir, I want to say that there should be 2 steps: 5 left side and 4 downside.
Hmm.
But sir, in answer it's only one, sir, 4 downside. Look, sir, only down 4. And
Down.
then
Okay, down 4. Then tell me. So what is the problem?
sir, 5. How can 5 automatically was pushed toward left side?
So that's clear. That is clearly explained already. Now just let me use a different color to explain your idea. See, we will not shift 1, 2, 3, 7, and 8, and 4 is all in the right position. Now it is clear.
Yes, sir.
So what you will do? What is our goal state? Now think and tell me. First see.
Yes, sir.
Now again I'm again writing the goal state. 1, 2, 3, 4, 5, 6, 7, and 8. This is empty. Now clear?
Yes, sir.
So there is a very simple answer. 5 is also on the right position. So we will not do any changes 1, 2, 3, 4, 5, and 7, 8. This 6 is on the not position. So what you will do, you will shift this one. So what you are doing, you are doing the down 6. And so how many steps are required to solve this problem? So that defines the our 1. So it means this would be the heuristic function. Now this is clear right now.
Yes, sir.
This is our solution. So we got our answer. So now at the end we can see. So after shifting this one, we had the 1 point, that is a 1, 2, 3, 4, 5, 6, and 8, and 7, and this is a blank. So here no shifting is required. So here we are getting this one. So this is our goal state. Now this is the point. From this point, you have another option. What is another option? Just look at this point. This is a part I'm taking, but look at its previous part. Look at its previous part. So its previous part, what was the previous part? The previous part was 1, 2, 3, 7, 8, 4, and 5. So here we have a 4, and here we have the 5 here, and 6 we have. I'm writing the arrow. This is the previous one. Okay,
Okay.
so this is the previous one. Oh, okay, am I right? So
Yes,
if
sir.
I'm talking, yeah, okay. So here you mean to say how we are getting the h equal to 3. Am I right?
Yes, sir.
It's very simple. It's common thing. So 1, 2, 3, 7, and 8 are on the right position. 4 is also right position. But here we need to think the possible shifting. It is possible. It's better idea we can leave. We have option we can leave. Else if you are not shifting, we have two option. We have two option. What was the first option? We can shift the 5 as we have seen the in this case. As we have seen here. Or you have the two option. Either you can go down or apply the route right 5, or go down, that is 4. You have these two options. So first option right 5 we have done. Now it is clear. So by which we are getting the hn equal to 1. Now it is clear.
Yes, sir. Yes, sir.
That is the point. So if you're see, this is the our rules of the start space search mechanism. In the searching, we have to see the all the possible paths. Maybe we can get the minimum heuristic function. If you remember the yesterday's class, we have seen the AO star algorithm where we have to find the other path. Maybe we can get the minimum cost. This is the reason we have to check this one. If I'm shifting the 5 down, although it is not required, but we have to check, as we have also seen in the our previous same example, at the time of down 3, although it is not required, but we have to check. So for checking purpose, what I'm doing, I'm just shifting here down. There's a 4, so I'm just downing 4 here, not here. So 6, 5 and 4, these are the 3 tiles which are not in the right position. So how many shiftings are required to do this one? So here hn would be 3. So this is the point. But from this point, I'm getting hn equal to 3 and hn equal to 1. So which is the minimum? This one. So I'm choosing this one. So for continuing my problem. So this is the reason you can look at this solution. After choosing the down 4, I'm not expanding the my solution again. So this is not required to choose. This is a reason.
Okay, okay. Got it, sir. Got it, sir.
Okay. See, look at this down 3. Although this point is not required. This point is not required. I'm just marking the cross. Because look at the black cross. This is also
Yes.
not required. But I need to check what are the possible paths. So we have to find the prominent paths to get our solution. That is
Yes.
my point. See,
Yes.
as a being a smart human person, we can sort out any problem in 1 or 2 minutes. But as a being a child, because if you're talking about the artificial intelligence, so our objective is to train the machine in the learning form. So as a being a child, the child will try to find the possible path. Maybe he or she can get the best path. So that is the reason we have to move into the down 3. We have to check the down 4 as well. That is my point. Now it is clear.
Yes, sir. Yes, sir.
Okay, so this is our problem where we have discussed this point, how we can get all the points. So ultimately, our objective was fulfilled to minimize the hn equal to 0. It means no shifting is applicable, no movement is applicable. So here hn is equal to 0. So we got the goal state. So this is our objective. So now this problem is clear right now. Tell me, this is the problem where we try to find our problem in the search space tree by using the heuristic function. So how we are defining the heuristic function? So based on the problem, we can have the different heuristic function. According to the my problem, I'm defining the this is the my problem. So this would be the heuristic function. So what is the my problem? So based on the x problem, I can define the heuristic function and I can write the heuristic function values. So that is the learning problem. If you have to understand the problem, what is the problem? So if we have n number of the problem, so n number of the heuristic function maybe. That is the point. Okay, so now let me write now 1 second from your side. So this problem is clear. This is the our problem is clear right now.
Yes, sir.
So it is seen from this example that is a state space tree we can say, or the search space tree we can say that the goal state is minimized from h3 or hn equal to 3 to hn equal to 0. So however, we can create and use several heuristic functions as per the requirement. So we can create and use several heuristic functions based on our problem as per the requirement. So it is also clear from this our example that a heuristic function hn can be defined as the information required to solve our given problem with a more efficient way. And the information can be related to the nature of the state, cost of the transforming from one state to another state, and goal node characteristics, and which is the expressed as a heuristic function. So heuristic function is basically composed by the various points. What is the problem? What is the nature of your state? What is the cost you are using? So that is the point. So heuristic functions will be depend on the problems only. We can't fix the heuristic function on the such problem. We have to understand what is the problem we have, and we have to define the heuristic function to discover something. And the purpose of the main objective of the heuristic function to provide the efficient solution of a problem. So this is the point. Now it is clear to all right now. Yeah.
Yes.
And any doubt in this problem? Now how we can define, how we can use the heuristic function? Now, any doubt so far? I can just move back to again this heuristic function definitions. I have taken this example to understand the problem and how we can do so according to the various way I have explained over here. And now I have given the solution over here. Now the student's problem I have sorted out with the different way. So now this is the point. Now What are the properties? That is the point. I thought 2 days back, if the student asked me the question search in the heuristic search algorithm, so what are the various property? That is the point. These are the very very important properties at the time of the interview. Anyone can ask you. So first one is the admissible condition. Yes, you can read and tell me in your way what is mean by the all these properties. So if you read all the points in your mind and tell me what is mean by the admission condition. Can anyone tell me right now? Everything is in front of you and read and think and tell me what is mean by the admissible condition. Because anyone can ask you the question, oh, you know the heuristic function, so what is mean by the admission condition? So if you not able to speak anything any at that moment, so everyone will know, oh, you just not go through the proper conditions or proper properties of the heuristic function. So here we have some steps or some points which describe the properties. So what is mean by the admissible condition? So it is written over here, an algorithm is said to be admissible if it return an optimal solution. So suppose I'm trying to solve my previous problem as we have seen the couple of the minutes ago. If I'm not getting the my solution, so it means my problem is not admissible and I'm not following the admissible condition. So because I'm not able to get the my solution, that is the point. So here we have to keep in mind the heuristic function I'm applying, it means I'm getting the admissible condition. Now this property is clear. I'm just marking right over here. You have any doubt? The admissible condition means that we are getting the optimal solution. If you are not getting the optimal solution from the or any problem, so we can say the our heuristic function is not justify the admissible condition. Now this is clear right now.
Yes, sir.
Okay.
Yes,
And
sir.
next one
Yes,
is
sir.
completeness. An algorithm is said to be complete if it terminates with the solution. I'm applying an algorithm to the my solution. After many trying, I'm just applying the same algorithm, but I'm not able to get the my solution. I'm stuck in a bad condition, and my solution is not complete. So if you are solving any problem and you are getting the proper solution, then you can say yourself and to the judge or the panel that I'm getting the solution in completeness. So this is my property. So solution must be admissible condition followed by and solution must be the completeness. It means I'm having the solutions. And now next one is the dominance property. Okay, you can read very simple. If there are two admissible heuristics algorithm, that is A1 and A2, so we can have the many algorithms like a BFS, DFS, or we can have the another algorithm. So from this point, each and every algorithm is also having the own heuristic function that is H1 and H2. So A1 is set to the A1 is set to dominate A2 if H1 is better than H2. Now I can take a very simple example. So just look at this point. Yeah, this. There are two students, A student and other is a B student. Then this student is giving the solution with the minimum time complexity and with the minimum space complexity compared by the B. So it means A student will dominate the B based on the solution. So same thing we have because the student who is having the heuristic function, the solution, the idea, the algorithm will be better than the B. B is also having the solution, but in terms of the some parameter, time complexity and space complexity, it is just providing the minimum time. It is just having the minimum space, so we can utilize this code to solve our problem rather than the P. That is the point. So dominance property like this one. And optimality property just as the name suggests, the solution must be optimal. We can have the n number of solution, but optimal our solution should be optimal. So that is the way. So these are the four important properties by the heuristic search algorithm must follow. So in our example, we got our admission property, admission condition. Okay, we are getting the optimal solution. Where the solution is complete, yes. So we are getting the completeness. we don't have the multiple algorithms right now, so we are following only the one simple algorithm to sort out the problem. Maybe we can apply the multiple algorithm, such algorithm. Of course, we can apply. We can sort out the same problem by the A star algorithm, or we can also sort out the same problem by the A star algorithm. So after this one, you can check which algorithm provides a better solution by the heuristic functions. So we can say this would be the better A star or A star. So that is the reason. And optimality property is definitely from the both algorithm or both approaches we are getting the optimal solution. But which solution is better? So dominance property will help you. So these are the four important properties we have to keep in mind. So that is the point. Now, anyone who need to ask any question from this point, these properties, so I can explain once again. Else, we can move to the our next problem.
No, sir, it's clear.
Yeah. Okay. So I have something to you. Just I would like to share the question to you. Can you able to solve rather than theory?
Sir, we'll
So
try, sir.
yeah, okay, good, good. So I'm not giving the much theory. This is the one problem I'm sharing. Initial state, start state I'm sharing, and goal state I'm sharing. Solve this problem and tell me the just tentative solution. This kind of a question may ask into the examination random values I can give you, and you have to find the optimal solution. Maybe there is a no guarantee after giving the some values you may not get the solution. So you will not be confused. Sir, I'm trying to many times I'm not able to get the solution.
Excuse me, sir.
Maybe the solutions does not exist in the our problem, so that will not satisfy the our completeness property. That is the point. Yes, okay, just try